Chapter 3, Section 4, Solving Multi-Step Inequalities. So these are similar to the multi-step equations, but obviously we're working with an inequality symbol as well. Take a minute, pause the video, and try to solve each of these three inequalities and plot each one on a separate number line. So looking at the first inequality, 9 minus 4s is less than 5. We want to isolate the variable, the s. So we're going to subtract 9 from both sides. We're left with a negative 4s. Now we divide by a negative on both sides, so the sign flips. You get that s is greater than 1, which means circle the 1. It's an open circle, and it's greater than, so it's going to the right. Interval notation, if you read it from left to right, it starts at 1, not including 1, so it's a curved bracket, and it goes up to positive infinity, which gets a curved bracket. The next one, we want to isolate the variable. We want to only be working with one variable, so get it to one side of the inequality by subtracting 4n from both sides. Then add the 3 to the other side. 2n is greater than 10. When you divide by 2, you get that n is greater than 5. So circle the 5. It's an open circle because it's not equal to. Greater than means going to the right. And again, interval notation, it starts at 5, not including the 5, so it's curved, and goes up to positive infinity. Finally, for the last one, you distribute the 3 to both terms inside of the parentheses. And we're distributing the negative 2. So this is what we get when we distribute. We're going to add the 2t to both sides and combine like terms on the right. So 4 plus 4 gives us 8. Subtract the 3. Divide by 5. You get that t is less than or equal to 1. So circle at 1. It's or equal to, so we're going to fill it in. It's a closed circle, and it's less than, so it goes to the left. Reading from left to right, interval notation, we're starting at negative infinity. We go on and on and on and on until we hit 1, and 1 is included, so it gets a square bracket. Again, take a minute to solve each of the following inequalities, and make sure you plot each one on a separate number line. This time, try to include interval notation on your own for each one. So here we have our solutions to our three inequalities. I'd just like to point out that here m is less than negative 3.5, so your circle should go in between negative 3 and negative 4, so be careful of that. Open circle for the second example, closed circle for the first and third. If you have any questions on these, please bring them up in class tomorrow, so make a note of that now. Now, getting into word problems, we had keywords for equations. We're also going to have additional keywords for inequalities. So when it's less than, you're going to see less than. But the difference here is it's going to say is less than. So make a note of that. All of these, for the most part, it is greater than, it is less than or equal to. When we had equations, we used the word is. It's the same thing here, but now we're saying it is less than. So that lets you know when to use an inequality symbol. Is smaller than, below. When it's greater than, it is greater than, it is bigger than, it's above. When it's less than or equal to, it might say it is less than or equal to. No more than is a big one. No more than means it has to be less than. So when you have that negative, it means less than. The maximum means it has to be below. At most does not exceed. Is greater than or equal to. The minimum means that it has to be more than that. At least means it has to be at least $300 or more. And no less than, same thing. So please copy down these phrases so that you understand when we get into word problems what they're describing. Please copy down this word problem. You're trying to decide what cell phone plan to choose. We have plan X, charges $30 per month, plus 2 cents per text. Plan Y charges $50 for unlimited text messages. How many text messages do you need to send in order for the second plan to be cheaper? So we want Plan X compared to Plan Y. We want the second plan to be cheaper, so we want it to be less than Plan X. We want Plan X to be greater than in cost to Plan Y. So let's say it's asking in 1 month. Well, in 1 month, Plan X charges $30 plus 2 cents per text. So we're going to have our let statement here, let T equal the number of texts. Now Plan Y charges $50 for unlimited, so no matter what, Plan Y is $50, and just like we have up here, we're going to make that 30 plus 0.02 T is greater than 50, and then we solve the inequality. And here we get that T has to be greater than 1,000. So you would phrase it as, in order for Plan Y to be cheaper, you must send more than 1,000 texts, because 1,000 texts wouldn't be enough. You'd have to send more than 1,000 texts, which means 1,001 or more, because you can't send half of a text message. Again, please copy the word problem. You're going on a field trip and need to choose where to go. The zoo costs a $100 fee plus $10 per student. The museum costs a $250 fee, but it's only $5 per student. How many students need to go on the trip in order for the museum to be a better deal? So we want the zoo to be more expensive than the museum. Well, we're going to let X equal the number of students. Again, you need a let statement for everything. Then we're going to set up the inequality. Well, the zoo is $10 per student plus the $100 fee. The museum is $5 per student plus the $250 fee. And we want the museum to be a better deal, so we want the museum to be less than the zoo, or the zoo to be greater than the museum. Well, first thing we need to do is isolate the variable, get it to one side of the inequality. So we get 5x plus 100 is greater than 250. Then we want to get the variable by itself. 5x is greater than 150. Divide by 5, and you get that x is greater than 30. So that means you must bring more than 30 students in order to make the museum a better deal. If you want to phrase that in a complete sentence, that would be the best way to phrase your answer. Again, copy down the word problem. You're at an amusement park and want to know what would be a better deal, buying the unlimited wristband or paying per ride. For the unlimited, it costs $60, or it can cost you $4 per ride. How many rides would you need to go on in order for the wristband to be a better deal? So we want the wristband to be less than in cost paying per ride. Well, it costs $60 for the unlimited wristband, so 60, we want that to be less than $4 per ride. If we let x equal the number of rides, $4 per ride. So this is a simple inequality. We divide both sides by 4. We get 15 is less than x, but we want it to be in the order variable, symbol, constant. So we're going to flip-flop the whole thing, including the sign. We get x is greater than 15, so more than 15 rides. If it said what's the least amount of rides in order for it to be a better deal, you would say 16 rides. Finally, copy the last word problem. You're at an amusement park and they have two different refillable souvenir cups. The first one costs $5 and has refills for $2. The other one costs $8 and $1 per refill. How many refills do you need in order for the second one to be a better deal? So we have the first and we have the second. We want the second to be a better deal, so we want the second to be less than the first. Well, the first one is $5 and $2 per refill, so let's let x equal the number of refills. Well, $2 per refill plus the initial $5 cost, and we want that to be greater than $1 per refill and the $8 initial cost. We're going to isolate the variable, so get it to one side of the inequality. You get x plus 5 is greater than 8. Subtract the 5. X is greater than 3. So how many refills do you need to get? More than 3 refills. Again, if it asked you what's the least number of possible refills you could get for it to be a better deal, you would say 4 refills because it's not less than or equal to, it's just more than 3.